you see worksheet 1C, internal normal forces and stresses for a member in a truss. And as you recall in engineering mechanics, the truss member is a two-force member. So given the cross-sectional areas of all truss members below is 4 inch square, so that is the areas of the transverse cut. And for the load and reaction shown, determine the normal stress on a transverse plane in member IH. So member IH, as you can see that here, member IH. Member of interest are this member IH there. So before we find out the normal stress, at the normal stress is the measure of the intensity of the normal force. So we need to find out the force, internal force in member IH. And for the truss, first we find out the external reactions at the support A and G, external support A and G. In this case, they already give us the external reactions at A is AY 25 kips go up and TY 25 kips go up. So we don't need to go to find out the external reaction. So with that, we can do either the section cut or troy cut, but this one, it makes sense to do a section cut to the member of interest, and the member that we cut, it go through IF, that the question asked, and here go through all three member IH, IF, and EF. And for the section cut, we can expose three unknowns, and this is absolutely three unknowns, and easy to consider the right section after you cut. So let's draw the free body diagram of that one and use the method of section. So with that, we have the method of section for the truss, and in this one we draw the free body diagram on the right side, free body diagram for the right side. So we have that HI, we have HF, we have EF, HG, and we have FG. So we have G, we have F, we have H in here, and we also have member IF. So from that we can have this is HI or IH. These reactions, the internal force is Fi, and the internal force here is EF. And for the dimension, we can have here 8 feet, and that is 6 inch. You have 6 feet there. 6 inch, 8 feet. So also 8 feet. So basically, the slope here is 1188. So 11 square root of 2. F. And then use the load. You see 25 kips. At F we have 15 kips go down, and of course we have the 0 in the GX direction, so we don't have to do that. So we only the question only find out the normal force IH, so you just take moment about F, so that the two unknowns Fi and EF, it will be go through that point, so it will generate no moment if we take moment about F. So take moment about F, assume counter clockwise is positive, so we have HI, which is the member of interest, times 8 feet, and then 15 go through F, 15 kips go through F, so it will not generate no moment, and then only one is 25, and it also about F counterclockwise, so it's positive 25 aphid. So from that we can have HI equal to negative 25 kips. What in negative mean? It means that HI or IH is 25 kips. For trust member, the answer it will be compressions. So that is the internal force for member IH. Now the question asks is, what is the normal stress on a transverse plane on member HI? So as you can see, transverse plane. So for that we can go ahead to find out the normal stress. Normal stress. Transverse, so it's perpendicular to the longitudinal axis. Let me put that member I here, and as you can see compression, so we have the force HI 25 kips go into the cut because it's the compression, and transverse cut, so this is the longitudinal axis of that members. Transverse is actually the section perpendicular to that longitudinal axis. From that, as you can see, we can have the force in that members for sure. From that we can have the P in this one, or the HI is also 25 kips. So any point, any transverse cut that you cut the member along IH, the force P is 25 kips. So from that we can have the areas of that cut. Here, A of the transverse is 4 in square. That is the question given, in square. So from that we can have the normal stress sigma equal to P over A. If that P in there over A, the area of the transverse cut, and that sigma it will be equal to 25 divided by 4, so it will be 6.25 units kips per square inches. So per square inch, so it will be KSI, and it will be compression. It's same the normal stress direction, same as the direction of the force, so it will be compression as well. So that will be the answer for the normal stress. And I suggest you with the same process we can do that for the worksheet 1C following.